Okay, this is Algebra 1, Chapter 1.1, Solving Simple Equations. And Chapter 1 is all about solving linear equations. But the first one is should be just review, but you can let me know if you want or not. So we're going to start with a simple problem, x minus 7 equals 6. It says equals negative 6. Okay, so we just isolate the variable. X is the variable, and if we want to keep both sides of the equation balanced, this is the equal sign, and this is where we balance. Everything over here is equal to everything over here. So if we're going to do the opposite function, which is typically how we do it, we're going to get x by itself. I'm going to isolate the variable, so we're going to add 7 to both sides. Okay, and a negative 7 and a positive 7 disappear and become 0. And they cancel each other out. So we're left with x on one side, and a negative 7 and a positive 7 gives us a positive 1 on the other side. Pretty simple, pretty straightforward. Now you do have to make sure you're remembering the rules for combining negative and positive numbers. And typically, if you have a positive and a negative, you just take the bigger one, the one farther from 0, the absolute value of the larger absolute value, I guess that would be the technical correct way to say that. And you just find the difference. 7 minus 6 is 1. And because 7 is more positive and 6 is less negative, then it stays positive, and that's where we go. And you'll see that in this next question. It's actually a little more confusing, and I'll show you what often is done wrong. Y plus 3.4, you can take notes with me, is equal to 0.5. Y plus 3.4 is equal to 0.5. We're going to subtract, just like we did over here. We had the opposite of negative 7 is positive 7. Here, the opposite of positive 3.4, let me change colors just for fun, is negative 3.4. And those disappear, leaving just y. But we have to do the same thing over here. Now, a lot of students are tempted to just come and just subtract. 5 take away 4 is 1, and 0 take away 3 is negative 3. But the answer is not negative 3.1. We have to remember what we did over here is we look at the absolute value, and the larger absolute value is 3.4. And if we subtract 0.5, we're going to actually get a different answer. See, this is 3.4 away from 0 in the negative direction. And if we start in the positive direction and we subtract 3.4, it's going to get, this looks like a good answer, but what we see here is that 4 take away 5 can't be done, so we borrow. 14 take away 5 is 9, and 2 take away 0 is 2. So we have either negative 3.1 or negative 2.9. Now I know it's negative because 3.4 is negative, and that's more negative than the 0.5 is positive. That's always something to think about. You got a number line, zeros here. If we say negative 3.4, this is negative 1, negative 2, negative 3. Negative 4 is over here, so negative 3.4 is somewhere in here. And positive 1 is here, so negative 0.5 is somewhere in the middle. We're subtracting these two. So it's really like we're taking this amount, and that's 3.4 away from 0. But we're subtracting it, so we're taking away 0.5. And 3.4 take away 0.5 is 2.9. So this is not a good answer, and you can use your calculator to prove it. You do have to make sure that you understand the rules of algebra, though. And a lot of times, a lot of students make this mistake over and over again, and they don't know why. Well, it's because our absolute values are distances from 0. We're subtracting this distance from this distance. And so if we just do that, 3.14 take away 0.5, that's negative. That's 2.9. And because this is more negative, this is more negative than this. This is only a little bit positive, then our answer ends up being negative. It's negative 2.9. Make sure we get that right there. All right, so that's pretty quick. We just might have confused some of you. You can go back and rewind and watch that again if you need to. H plus 2 pi is equal to 3 pi. Now this looks hard, but it's really not. We're going to subtract 2 pi, and we're not going to change pi into anything like 3.14 or 22/7 or anything like that. We're just going to subtract 2 pi. And it's like having another variable. This becomes 0. 2 take away 2 is 0. So 2 pi take away 2 pi is also 0. So h is left, and you just have pi over here because 3 take away 2 is 1. So 1 pi is the same as just pi. That was easier than you thought it was going to be. That's the 3 examples they give us for solving equations using addition or subtraction. But we've got to do some multiplication and division too. So we've got some examples for that. We've got negative 3/4 n is equal to negative 2. And this is where if fractions are trouble for you, we're going to need to review before we move on. Fractions can be very difficult. They can be scary. They're not really that hard, but they feel like it. We've got negative 3/4 n equals negative 2. So to get rid of a fraction, the best way is to multiply by another fraction. And we're going to multiply by a negative 4/3. A negative times a negative is a positive, so we're gonna go ahead and do that. And the reciprocal of 3/4 is 4/3. So this would be positive 12/12, which becomes 1. But remember, what we do to one side, we have to do to the other. This is supposed to be a 4. And we come down here and we kind of rewrite that. 4 cancels with 4, 3 cancels with 3. And 2 and 3 don't cancel, so we just leave that alone. We've got n. Negative 2 times negative 4 is 8/3. And that's a good answer right there. You can stop there. Now, if you're somebody that really needs to have, in algebra, a lot of times we'll leave an improper fraction because they're easier to work with than mixed numbers. And the mixed number would be 3 goes into 8 twice, so 2 and 2/3. That would be the mixed number. These are equal, but 8/3 is fine. We'll just leave that alone. Okay, so the next one is pi. They keep throwing things at us like that. Pi times x is equal to 3 times pi. Now again, we're just going to divide by pi. See, pi times x, I said 12. We're going to divide by pi. Pi times x is a multiplication. So the way to work that over is either to multiply by the reciprocal, which would be 1 over pi. And we could do that, or we could just divide by pi. Either way, should I change color just to make it interesting? Either way, pi over pi and pi over pi, we divide both sides by pi. And anything over itself is 1, like 7 over 7 is 1, right? That means that pi over pi is equal to 1. And I guess you could say that tree over tree is equal to 1. That's just a little bit of silliness, but it helps us highlight the fact that pi over pi is 1. And so x just becomes 3. And we thought that was going to be a really hard question, but it's not if we remember what we're doing. Okay, so I think that's it. There's a real-life application problem in there and some other things like that, but you just have to ask me for help if you get stuck on that. We just have to make sure we understand the basic of adding and subtracting, multiplication and division for linear equations.